All right, good morning. Welcome back to Calculus 2. We are looking at the series from one and goes from 1 to infinity of the arctan of n over n squared. We're going to do this by the comparison test. So the first thing I'm going to do is saying the limit as n goes to infinity of the arctan of n is going to be equal to pi over 2. Okay, so if you take, and then goes off to infinity, arctangent of infinity, not really, but a really big number is pi over 2. So this series here must be less than or equal to, so we're going to say this, n is equal to 1 to infinity, arctan of n over n squared must be less than or equal to pi over 2 over n squared. Okay, so that's pretty much your first little thing to say. Now, what we can say about something over some constant over n squared is we're going to say that this converges by the p-test. Okay, so some constant over n squared, summation from 1 to infinity, converges by the p-test. Okay, which is always a nice test to be able to have. It's very convenient that they do that for us. Okay, so since this arctan of n must be less than, must be smaller than something that does converge. We know it does converge because of p-test. We're going to be able to say that the arctan of n over n squared converges by comparison to the p-test. So arctan of n over n squared, sum from n goes from 1 to infinity, converges by comparison to p-test. Okay, and that's pretty much all there is to that. These are nice problems. Comparison test is very powerful if you can just show that your series is smaller than a series that you know that converges. If you know that it's smaller than it, you know this piece converges, then the kind of like the squeeze theorem, then we can also say that the series we're comparing to also converges. Okay, I'm going to say thank you very much for watching my video. We'll see you in the next video and take care until then.